Hello students, welcome back to WAEC past questions revision class brought to you by IOTA virtual learning platform. I am still your tutor, Olabisi Olawoye. We are going to treat some questions here under scientific measurement. The first question here is on chemistry practical. Why is it necessary to take burette readings in titration to 2 decimal places? Now, don't forget the topic we are treating is scientific measurement. So everything under measurement, which is precision, accuracy, fundamental unit, derived unit, conversion of units are very, very important. And so in burette reading, it is important to take our readings to 2 decimal places so as to get our precise values, because most of these values can be used to calculate other parameters. Take for instance now, you have a burette. Burette is actually one of the materials in titration where which usually contain acid. Scientists will fill them with acid. Then the pipette contains the base. That is an acid-base titration. Now, if the burette is calibrated and is 50 cm cube, the next one here will be 40, then 30, downwards. Now, you will notice that if you round up your values, maybe you have titrated and the volume of acid used, you want to take the readings of the volume of acid used and it's reached this level. Maybe as you are looking at the liquid, you will see it in form of curve in the burette. So that curve is called meniscus, and we have the lower meniscus. That's we trace the lower part of the curve. That is where your readings will be taken. So most times it may not be on the whole number. So if you have this now, for instance, this is between 50 and 40. 40 is here, 50 is here, and this is like 40, 42. Now, let's assume that we have another burette that is taking readings, and between 40 and 41, 42, we have readings there. Let's say this is 40, this is 41. Now, between 40 and 41, after doing the carrying out the practical, let's assume the lower meniscus is found here. So this is like 40.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9, 10 before we get to this point. So in this case now, we are going to get an accurate value rather than rounding up where we have 41, 42, 43, and then we just round up here. So between 40 and 41, we have points, which are decimal fractions. So the more or the higher the decimal fractions, the more precise your answers are. So it is important to take your readings to 2 decimal places. So when you are taking readings, for instance now, you will have 40, maybe your titer value is 41.50. You don't need to round up your values to 42 or write 41. The 0.5 there is very, very important, as a drop of acid or base or a drop of any solution in titration can change your result. That is, in titration where color changes are necessary, if you add a drop of base or acid and the color change, that can actually turn around the reaction. Definitely, minute values like 0.1, 0.2, 0.3 like that can also make a difference. So they all count, as at times you may be asked to use these values to calculate other parameters like the molar mass, number of quarter of crystallization, which are already fixed, and you're expected to get a particular value. So when you manipulate or estimate your answers, you may not get what you're expected to get. So it is important to take burette readings to 2 decimal places. But you can't get, when you are taking your readings in Burette, you can't get something like 41.05. It is not possible, except you have repeated your experiment and then you calculate the average of those readings. You can get something like this, but not like this in the Burette readings. I want you to take a close look at I want you to take a close look at any Burette in the laboratories and learn more on these readings. The next one is the titration readings. Why is titration readings repeated in quantitative analysis, which is also known as volumetric analysis? This is similar to the first question. They are asking here that why do we repeat experiments? Even in generally, when we are carrying out experiments, it is important to repeat our experiments to at least to be sure of our answers. So it is important to repeat our experiment to get concordant values. What are concordant values? Values that are very close to each other. When you repeat experiments and you get values that are close to each other or almost the same thing, it's a signal that our experiment is accurate. Take for instance now, as WAEC student, you will be asked to take or make tables of Burette readings in titration, which is usually in this form: rough titration, first titration, second titration, third titration. Now, your tables of readings will be in this form. So you have your final volume of acid used. Initial will be under here, volume of acid. Then we have volume of acid used, which is the difference between the final and the initial. So when your initial is 0.00 here, assuming you fill your Burette up to 0.00 at the beginning of every titration, wherever the acid gets to, the level of the solution the Burette gets to, that is where you take your readings. So readings will be here. Let's assume this is 41.50 as a rough, then others are 40.90, 40.80, 40.70. Now from here now we can see that the more you repeat the experiment, the more accurate the results, and that 40.80, 40.70, they are very 40.70, they are very close to each other. So most times when we are carrying out practicals and WAEC, we make use of values, but WAEC wants you to or expects you to make use of values that are in concordance to calculate your average. Now you cannot use, when you calculate the difference of the final and initial, you have your answers down here: 40.90, 40.80, 40.70. You are expected to select the first, any of the last two or the last three that are in concordance. You may decide to choose 40.90 and 40.80, find the average, or find the average of the three, provided the difference between them is just 0.1 or 0.2. So you can see here that repeating experiments will give us the chance to use the correct value. Now, assuming you stopped at the first and second experiment, you will see the gap, that the first experiment gave us 41.5, the second one 40.90. So the difference is 0.60 plus or minus. And so when you are carrying out experiments, it helps, and you are repeating it, it helps ones to get values that are in concordance. What is the concentration in gram per dm cube of a compound weighing 50 gram in 250 cm cube water? What is the concentration in gram per dm cube? That's the next question. Now, how does this concern us as well? This is still under calculation. It is still under the calculation of titration, where our answers must be in gram per dm cube and not gram per cm cube. Now, if you take a close look at this, you were asked to change 50 gram or express 50 gram into 50 cm cube back to gram per dm cube. Now, 1 dm cube means 1000 cm cube. So we have a formula that we use in calculation of titration. Molar concentration here. Molar concentration is in mole per dm cube is equal to mass concentration in gram per dm cube over molar mass, which is in gram per mole. So in this case, how do we get this gram per dm cube? Because that is what is in the formula. But in the question it was cm cube. We need to convert the cm cube back to dm cube. So I want you to go back to 2000 and from 2023 downwards, even 2024, you will see that there are some questions there, especially in 2015, 16, 17, it was repeated. Most of the mass concentration that was given the questions were expressed in gram per cm cube and not in gram per dm cube. So as students, you're expected to convert it first before you use it directly in your calculation. So to convert this now, 50 gram is in 250 cm cube. So how many gram will be in 1000? You can just do it directly that. Since 250 can be, you can get 250 4 times in 1000. So if in 250 we have 50 gram of the compound, how many of such will you get in 250 in 4 places? That is 200. Or just cross multiply and get your answer. That is 50 times 1000 equals to x times 250. Dividing both sides by 250. 4. So we have a 200 gram per dm cube. So you will use this 200 gram per dm cube in your calculation directly instead of using gram in cm cube. Then the next question here, which also concerns us as chemistry students, is on electrolysis. This is also a vital aspect. You will see a part there which is conversion of hour to seconds and minutes to seconds. You were asked to calculate the quantity of electricity using Q equals to IT, where I is the current and T is the time. Q is the quantity of electricity which is in coulombs. Now, the issue here is not using the formula alone, but getting the correct conversion, because the time must be in seconds, so you are not expected to use the time given here, which is hour and minutes directly. You're expected to convert it to seconds. And so as science students, you must be able to do all this conversion, as this is very important, so as to get the correct answer. So here now, converting 1 hour 20 minutes to seconds, 1 hour to minutes will give you 1 times 60 minutes, then to second multiplied by another 60, which is 3,600 seconds. Then the remaining 20 minutes we'll have to multiply by 60 seconds to give 1,200 seconds plus the 3,600 seconds. Everything gives us 4,800 seconds. Now, it means that using this formula, we have Q as the current here is 0.4 and the time is 4,800 seconds. So getting our answer here, 4 over 10 times 4,800 seconds. So the answer is 960 coulombs. That is the final answer. And then the last part here that I also want to point your attention to is on the conversion of gram to kilogram, meter to centimeter, centimeter to meter, and so on. This is also useful when we are dealing with units and when we are dealing with mass and volume, especially as science students. Now, for instance, if you want to change or convert your 100 gram to kilogram, you know that 1 kilogram contains 1,000 gram. So how many kilogram will be in 100? So that is 1 times 100 equals to x times 1,000. So dividing both sides by 1,000, we have 1 over 10. X is 1 over 10, which is 0.1 kg. Now, this is very, very important, especially when we are dealing with some calculation questions. So the last part here is converting centimeter to meter. And that's we can get in these questions, 300 centimeter to meter. Now, how many centimeter makes 1 meter? 100 centimeter actually is equal to 1 meter. So 300 centimeter will be 3 meter. Or you can use this method, cross multiply, and still get a similar answer. That is 300 centimeter equals to 1 meter. So, 100 centimeter equals to 1 meter. 300 centimeter will be what? X. Cross multiply, we have 300 times 1 equals to 100 times x. Dividing both sides by 100, you have our answer as 3 meter. So with the correct knowledge of conversion of units, and this will help you to be able to get accurate results when you are dealing with anything that has to do with measurement as science students. I would advise you to go back to your past questions, study the past questions, and watch out for all this I've said. If you go back to the chemistry past question from 2015, let me just start from there upward, you will see that some instructions were given where you were asked to repeat your experiment to get concordance values. Then get yourself exposed to as many questions as possible that has to do with calculation and see how you can convert values from one unit to another. Thank you for being patient till the end of the class, and watch out for the next video, which is on scientific method. And I advise you to follow this teaching. Get yourself acquainted with WAEC past questions so as to prepare adequately for your exam. This is brought to you by Hayota Virtual Learning Platform, and the topics here has been carefully selected based on the WAEC syllabus. So please watch out for other beautiful videos on interesting topics that we have as we prepare for our exam. Take care.